I wish you all warmly welcome to this demo tutorial series. And today, Johanna Silvennoinen will give tutorial on cognitive and affective processes in decision making. And this is part of our activities in our thematic research area, demo decision analytics utilizing causal models and multi-objective optimization. So once again, you are all warmly welcome. And Johanna, please go ahead.
Yes, thank you, Kaisa. I'll start to share my screen. So now you see the presentation.
Right.
Yep. So, as Kaisa mentioned, my name is Johanna Silvennoinen, and I'm a postdoctoral researcher of cognitive science here in the Faculty of Information Technology. And besides my work in cognitive science, I also work in Kaisa's research group. And the topic of today's tutorial is cognitive and affective processes in decision making. As mentioned in the abstract, the contents of the tutorial are as follows. First, we go and look what cognition and affect means. Then I talk about decision-making processes, different theories of those. Third, cognitive biases, following with cognitive load. And last, cognitive control and uncertainty. And then there's references. There's in total of 5 slides of references, so quite a bit. So some of the issues presented in this tutorial are in introductory level, but I provide the references for you if you want to dig deeper into the topic. So, what is cognition and what is affect? First of all, cognition, by stating it briefly, those are mental processes in human mind. Or to put it a little bit in the longer words, it's the mental action or process of acquiring knowledge and understanding through thought, experience, and the senses. This is the Oxford Dictionary definition for cognition. And the cognitive processes are, for example, thinking, memory, attention, judgment, problem solving, language, imagination, perception, and planning, to name a few. So this is cognition. And then we also have this related concept that is really important, especially in terms of decision making, and it's metacognition. It means that how one reflects one's ways of thinking and knowing, and how to use particular strategy for problem solving or decision making. And it can be divided in 2 components. It's about your own knowledge about your own cognitive processes, and then the regulation of cognition. Metacognition has been studied extensively, for example, in terms of meta-memory, because commonly people don't remember as the way they think they do. So in order to understand memory processes in different contexts, we need to have this metacognitive approach, which combines usually objective and subjective measures to understand really how the process occurs, so that we have some data that indicates the exact correctness, for example, of the memories being asked, and then the subjective understanding of your own memory, which also guides the whole process of remembering something. And then there's this little quote at the end of the slide. The adjective cognitive, especially in conjunction with the word computing, seems to be a trendy buzzword in the artificial intelligence community and beyond nowadays, from 2019. This is an article published by Springer, even though it's sort of like everyday language expression. But this, of course, is something that is pursued quite heavily nowadays and highly important to put the human mental life in focus. Then one important aspect about cognition and cognitive processes are mental representations. Mental representations are also sometimes termed as cognitive representations, but mental representations is much more established concept. And mental representations represent something external thing, object, concept, or idea. We can also mentally represent something that has never happened. For example, representing possible futures with different kinds of items that or issues that are not invented yet. So mental representations are not dependent on the external stimuli. There's this famous painting by Magritte, Ceci n'est pas une pipe, so that this is not a pipe. I think maybe quite many of you have seen that. It illustrates the difference between pictorial representation and mental representation. So the pipe depicted in the painting is not an actual pipe, but it's a representation of it. Then there are many different kinds of concepts related to mental representations, for example, schemas. Schemas are considered as cognitive shortcuts, and they are used for quick judgments of stimulus suitability to expectations. And schema theory by Andersen is the basis theory for many issues dealing with decision making, for example, in understanding cognitive load. To give an example of schema, for example, we might have a schema of bicycle, which is sort of like an abstraction of all the bikes that we have encountered. It represents some prototypical features of bikes, and whenever we confront another bike, we quickly match the incoming sensory input to the existing schema. For example, nowadays there's lots of different kinds of bikes, e-bikes and fat bikes. So we do quick judgments of the new encountered stimulus on the basis of the schemas that we have developed. So these are like ways to structure knowledge. And then also in terms of the schemas, they through familiarity, that is the how often we are exposed to something at the simplest form, of course, feeds the schemas and make those more established. And in information processing paradigm and information processing fluency, these sort of issues are explained with prototypicality and familiarity, and these function through schemas, and these minimize cognitive processes and the effort paid when trying to understand some information that we encounter. Then there are also different related concepts, for example, mental models. Mental models are mental representations that depict some relations of some aspects, how they work together. We have many different kinds of mental models of how things interact with each other. Then there's mental contents, that are the mentally represented information contents of mental representations. And for example, mental maps, that are our representations of spatial information. So these are like the very basic concepts of related to mental representation and how these affect information processing fluency. Here at the left side, we have an image of an office room from some American university from the 80s. I don't remember from what university, but still the context university is important in this, because this experiment was designed to understand how existing mental representations affect what we perceive and what we remember. In these experiments, students were instructed to enter a work office, a room in university building, and after they have went there, they were asked to report what kind of items or objects they saw in there. So before entering the room, they of course create mental representations of the issues that they expect there to be, and which highly influences that what they exactly see in there. For example, there's a skull in the shelf, so that was not reported because that's not something that you usually expect to encounter in a context like this. And then moving to affect. Affect refers to all subjective experiences with valence, and it can be considered as an umbrella term. And valence is like positive and negative. And emotional themes for valence can be, for example, sadness and joy. So affect can be considered as an umbrella term. Affect also involves concepts that are related to it. For example, emotion. It refers to whole process or event. Feeling is the consciously represented part of emotion. And mood is is sort of like a state of mind. So no contextual stimulus required for this type of affect. But then there's this core affect theory, basic emotion theory, and appraisal theory. So these three are the three most known emotion theories. And these have little bit different kinds of conceptualizations of the different concepts. But this, what I just presented, is quite a general one. And core affect theory is based on circumplex of emotion. It depicts affect in terms of valence, dominance, and arousal. Here we have this kind of image by Bradley and Lang. It's a SAM method, which is based on the core affect theory. And core affect theory is usually cited by, that is mostly advanced by Russell. And this SAM is a semantic differential method to examine emotions in terms of the first line is valence, then the second one is arousal, and the third one is dominance. So different emotionals or different feelings can have different sort of, that they, in the semantic differential, that they posit in different ways between these three dimensions. For example, sadness with valence is here in the negative. It can be in different ways arousing, usually in somewhere around here, and the dominance depends on the intensity of the experienced feeling. And these different kinds of methods have been developed because it's really difficult to study emotion process and how these occur. So this is one attempt, and especially because the verbalization of feelings is also a difficult task and requires quite a lot of reflection. So people have pursued to develop this pictorial based pictorial-based methods that the verbalization process wouldn't intervene in the measurement. Then there's this basic emotion theory, which is often cited to Ekman, and it considers that emotions have neural physiological basis. For this basic emotion theory, there are different methods also developed to detecting this. For example, different video recording systems where the different areas of the face is coded for different basic emotions. And since the 17th century, there have been, for example, books that have depicted different kinds of facial expressions to be expressed in paintings, for example, to convey different emotions. So that's one way of approaching the topic. And then the third one is appraisal theory that has been in focus in, for example, in our research in cognitive science, because it considers the affect as a cognitive process of the significance of the event to an individual. So it involves the cognition to the emotion process. Here at the end of the slide, there's a link to my Google Scholar profile where you can, if you wish, you can look. We have quite many articles in which we have utilized the appraisal theory as the way to explicate cognition and affect in human-computer interaction. So, in order to understand affect, we need subjective and objective measures. And usually the best way to approach these is to combine these both. Affect has also been studied in many different fields during the past 2 decades. In human-computer interaction and user experience research, has been in focus for quite a while now. There are different methods developed in understanding it, and maybe the most central authors in this are, for example, Mark Hassenthal, who has divided the process to pragmatistic and hedonistic components that have different kinds of goals. This also can be seen to highlight more cognitive aspects and more affective aspects. If you want to look more about affect, how emotion has entered the research area in various fields where technology is involved, there's this affective computing chapter. It's from the Interaction Design Foundation. There's this Encyclopedia of Human-Computer Interaction, which is really nice. There's over 50 chapters of different central topics. And the logic is that there's the one of the main authors in that specific research area writes an introduction to the topic, and then other authors comment the introduction. So it's quite an efficient way of understanding these research topics and how different researchers see those differently on the basis of their research. Then I give you this one example to highlight how cognition and affect are intertwined, because really often those are discussed separately, but in fact they are in our mental processes, those are highly intertwined. For example, if someone has some injury that the affective processes are not functioning properly, it goes into this kind of situation that whenever encountering some new information to be evaluated or judged, the cognitive mechanism allows you to do this evaluation and judgments. But if the affective side is not functioning, then the consistency in these evaluations diminishes. So affect is also considered as the part that makes things meaningful to us. So that as one example. But here the four are also titled as universal principles of design, and they relate to how we can strive towards designing something that people would like, prefer. And these combine, many of these combine cognition and affect as the important dimensions in these principles. First one is maximum effect for minimum means, which means that ideas and models based on few elements solving or explicating a larger problem or phenomenon with low result, so that you put low cognitive effort, but you gain a high impact, are preferred. So whenever this kind of principle can be applied, it increases the possibility of that the information presented to a human would be preferred and liked. One example of this is information visualizations, so that if we can effectively communicate some big ideas and models, but we can do that with few elements, those are something that should be done. The second one is unity in variety, and it's more on the perceptual level, usually utilized, for example, in design practices in the surface level of the objects. And it optimizes the balance between unity and variety. Unity, creating something that is easily grasped, cognized effortlessly, but then it needs to have something that differentiates from the totality of it to make it meaningful. So here the unity would refer to cognizing the sense-making aspect of it, and variety of something that is more affective. Third one is most advanced yet acceptable, also titled as Maya principle, and it functions more in the cognitive level. It focuses on the balance between novelty and prototypicality, or prototypicality is also often studied with the term familiarity. And this principle has been examined in many contexts, from user interfaces to furniture to paintings. So most advanced would be the affective side, and yet acceptable would be the safe cognitive sense-making part of it. And the fourth one is optimal match, multimodality, continuity, and coherence of sensory information and impressions. If we want to effectively communicate something, if we focus on delivering the same mental information contents of mental representations, for example, elegance, if we focus on communicating elegance through sight, through sound, through touch, then the overall impression is stronger and the information is processed fluently. So these are the 4 often utilized principles to understand how people balance between sense-making and affective side of. Then at the end of the slide, there's a reference to one of our articles in which we have tried to combine specific design features in user interfaces for specific experience contents, because the 4 principles presented in these slides, they have more predictability when we are designing something for humans, because they function in a higher level. But if we go, the more we go towards the actual artifact, the more complicated it becomes, because there are many different kinds of, for example, visual elements as the constructing units of pictorial representations, and they can be in numerous different combinations, and there are contextual features and cultural features and many different issues affecting the predictability of this kind of more detailed approach. But in this article, we try to combine and explicate this process with the theory of predictive brains, which can be also considered currently as the grand unified theory of cognition, because it incorporates many of the cognitive and affective processing levels. And then when we talk about affect, and especially in decision making, we need to consider about emotion regulation, because it highly affects the overall decision making process, and of course also the quality of the decision outcomes. So these are different kinds of control strategy for anticipation or experienced emotion. It focuses on controlling what emotions we have when, how these are experienced, and how these are expressed. And these are divided in antecedent-focused emotion regulation and response-focused emotion regulation. So before and during. And the two most common strategies is cognitive reappraisal, and it's for the antecedent and antecedent focused before the actual event, and it reduces risk aversion, but it's accompanied with high arousal impulsive decision making. So it has the prominence of reducing risk aversion, but then it also leads to high arousal impulsive decision making. The other one is expressive suppression, and it focused on the response-focused emotion regulation, something that is experienced and involves inhibiting different kinds of behaviors. The effectiveness of these is cognitive reappraisal is reducing emotion experience so that we can more focus on the cognition and the beneficial effects, so that while incorporating these strategies, especially the cognitive reappraisal, it reduces decision-making biases, as we are more reflective of how our emotions affect the decisions that we are going to make. So these are also important. Then how cognition and affect are seen in judgment and decision-making research. This JDM is the abbreviation that is often utilized to combine different studies where judgment and decision-making is involved, because it's a quite vast field or fields from psychology, behavioral studies, economics, reasoning research. So JDM is one way of combining these different lines of research. But decision making is considered as a high-level cognitive process because it builds on other cognitive processes, and it involves various stages. It builds, for example, on perception, and it requires attention-guided encoding and evaluation, then retrieval from memory or external sources, prediction, response, and post-decision evaluation, just to give an overall idea of the whole process. And then the decision making is based on its essential element. It's the process of choice. And it means that choice is a process of selecting and evaluating preferences among alternatives, and it's influenced before the judgment is made by perception, recognition, and judgment, and after the choice is made by feedback and learning. So decision making as a high-level cognitive process, and the essential element is the process of choice. Here are two citations from 2017 and 2008 that refer to the sort of recent advancement in JDM research and what we are lacking. In terms of what Gonzalez has stated, there are many cognitive processes in decision making that has not been studied extensively until now: perception, recognition, feedback, and learning. And according to Weber and Johnson, affective memory prediction processes have only recently emerged as explanations of judgment and choice phenomena. So even though JDM has been studied extensively for decades in different research areas, there are still a lot of issues to be done. Then, cognition and affective in choice of strategy. Affective states influence the choice of what kind of information processing strategy people execute. For example, if we consider this as through the valence component, happy mood often leads to heuristic top-down processing strategy that we rely on more information gained through experience and don't pay so much attention to details. Sad mood often is inhibited by systematic bottom-up processing strategy, so that we do not rely so much on understanding obtained through experience, but we focus on the details at hand. In some experiments where affect is studied, there's also this kind of like a control questionnaires where the affective states are questioned or are asked before entering the experiment in order to understand how the affective states is affecting the overall results of the experiment. I haven't seen much of this kind of issues in JDM research, but like in experiments where they would study something different, but they would acknowledge how the pre-existing affective state affects the whole decision-making process and the outcomes. So these are like two basic understanding of how the different strategies are conducted. Also, the different tasks involve cognitive processes to different degrees. Attention is highly involved if there's a judgment to be made on the basis of description in numeric or graphic form, and it accounts for a larger proportion of response variance in decisions. And on the other hand, memory and learning are important in decisions from experience, and the information of outcomes and likelihood by trial and error sampling of choice options over time. So it follows different kinds of process. And then also affective processes are more important in dynamic decisions under uncertainty, whereas analytic evaluations play a larger role in static risky decisions. So depending on the decision-making contexts, we need to understand how this affective side and cognitive side, what kind of role they play. And the second part is about decision-making processes. And if you have any questions of the first part, please don't hesitate to ask. You can also, of course, ask questions at the end of the tutorial, whatever you wish. So, the first issue to introduce is the open loop and closed loop view on decision making. This open loop and closed loop view is a book chapter by Cleotilde Gonzalez. She's a research professor of decision making in Carnegie Mellon University, and this book chapter is from the book of or the chapter is titled as Cognitive Scientific Perspective to Decision Making from 2017 Oxford Handbook of Decision Making, if I remember the name of the book correctly, but it's in the reference list. But majority of decision making theories until now or until recently exhibit this open loop view, that the decision making process is considered as linear, starting from something and progressing like this. So it's the most common conceptualization of decision making process, and it's based on explicit presentation of alternatives, probabilities, and consequences of outcomes. Then the closed loop view here on the right, which Gonzalez is in favor of, it represents the dynamic decision-making process, that it can be conceptualized in this manner with the closed loop view. So it's interactive, it's influenced by goals and external events, and it's considered as a learning process. So it's highly dependent on information gained from experience. The X means here experience to save some space, and it's highly feedback dependent. So it's an iterative loop. And it doesn't often contain explicit option descriptions, but the alternatives unfold over time through the iterative process. These two models, and especially the closed loop view, has emerged through the description experience gap that is seen important in understanding these decision-making processes. So it deals with how information about the problem is acquired. There's differences whether it is acquired from description or experience. So similarly as cognition and affect are usually seen as these dichotomic ends of one continuum, even though they are highly intertwined. The same applies to these studies on decision-making processes, that these are usually considered as in a dichotomical relationship. These have also been pinpointed to different theories. For example, prospect theory by Tversky and Kahneman, or often stated also as loss aversion theory. It has the potential to explicate decision processes based on description, and it usually follows the open loop model. And according to Gonzalez, there is no comprehensive model of explaining decisions from experience yet, but she has proposed this computational model of, if I remember it correctly, IBLT, instance-based learning theory, which follows the closed loop view on decision making. And later on in this tutorial, I present the fuzzy trace theory. That is one alternative for the decision-making process explicated from the view of closed loop. So there are many dual process theories. As I just mentioned, the prospect theory is one of those. And a recent article about Evans and Stanovic, they have tried to, it's like a argumentative review paper that they go through different kinds of criticism that different dual process theories have obtained. And this table is from that article, and there's this type 1 processing that is considered as intuitive, fast, parallel, usually related to biased responses, and majority of the processes occurring in our daily life are based on this type 1 processing. And then type 2 processing is more cognitively demanding, reflective, and it overrides type 1 processes when needed. And typical correlates are listed here. There's also research which tries to pinpoint these old mind and new mind to these different types. But according to Evans and Stanovic, the only attributes that, or the defining features that they stand by are here. So even though, for example, Kahneman has made the type 1 and type 2 processing quite popular, it's still, there's a lot of research trying to figure out the relations and the descriptions of these and what these actually stand for and what is the explanatory power of these dual process theories. Stanovic was the first one in 1999 to present this type 2 and type 1 and type 2 processes, and there used to be system 1 and system 2, but they have been now labeled as type 1 and type 2 because there are more systems in type 1 and type 2 than just one system. So the same Stanovic is also in this article. And there are several key belief fallacies of these type 1 and type 2 processes. It's often considered that the type 1 process is always responsible of cognitive biases, and the type 2 is the one that always corrects responses. And then, for example, the expert decision-making, intuition and preferences would belong to the type 1 processing, which is a little bit too simplistic. But we look more into this in the fuzzy trace theory. Often also fallacies are that type 1 is contextualized and type 2 is abstract. And also there's this belief that fast processing is necessarily indicative of type 1 processing, which is not the case in the fuzzy trace theory, which we have here next. So the expert decision making a fuzzy trace theory perspective, FTT. Sorry, I have to go to the kitchen quickly because my coffee machine is apparently breaking down. It's making a horrible sound. Just a second.
Okay.
It's a coffee machine but then back to the FTT. So it's a dual process theory of memory and reasoning, and it has originating alternative to HB approach. HB is heuristics and biases approach. it's based on development, and the development is seen as a process of acquiring meaningful experience of novices and to develop from novices to experts. So it involves learning. And the overall development process leads to more, just not only knowledge acquisition, but the reliance on GIST representations reflective meaning. So not only processing and remembering verbatim details, so it's not only description based, but it tries to combine the description based and the experience based views to decision making through development. It's also sort of counterintuitive because since Tversky and Kahneman, there are also many biases that decision makers have, and usually decision makers, expert decision makers, are more biased in their area of expertise, but they make faster and better decisions in real life situations. So that's the counterintuitive aspect to expert decision making. And many of these dual process theories also, which involves expert decision making, are studied, for example, in experiments that have novice and expert decision makers to understand what kind of biases are exhibited. So the FTT is based on two types of memory representation. First one is verbatim. So it's symbolic surface mental representations of the stimulus, not stimulus itself. So there's the difference of the pictorial and mental representation. So it's symbolic representations, for example, of exact words, numbers, and things like that. And the second one is GIST, and it's symbolic mental representation of the essential substance. So those can be seen as the description-based and the experience-based, or those can see to be referring to those. So the overall, the process is developed from the verbatim into the GIST-based processing. And if it develops to the GIST-based processing, it's more fluent, and it's based on increasing conceptual insights from experience that feed the GIST-based processing. Reliance for both to develop from experience, GIST-based preferred via expertise. So of course, the way you rely on verbatim or GIST processing also both develop from experience, but the GIST-based is more preferred because it's more fluent and doesn't involve so much surface level details to be acquired. But the FTT differs from the heuristics and biases satisficing term that we come up with the decision solution that is not optimal, but we can live with it, because this based processing is based on meaning. So it has a different outline on this topic. And talking about GIST, we might think that it doesn't involve heavy cognitive effort, that it's intuitive all the way through, but it involves cognitive effort, but it focuses on understanding the essence, and there are many experiments in which this has been seen. So, as I mentioned, that the counterintuitive aspect of this FTT, the expert decision-making biases are often in this. If we try to explain the dual process theory of decision-making with this FTT, then the biases are false memories, framing effect, So the framing effect referring to that if the information is presented with as a positive one, it affects how the decision outcomes is seen as a positive one, and the same for the negative one. So that results as a framing effect bias. Then also often occurring bias is the conjunction fallacy, in which specific conditions are more probable than a single general one. And then fourth, the hindsight bias, that recently acquired knowledge influenced the recollection of past information. So according to experiments of FTT, these are the most common biases in expert decision making. And even though there are many experts exhibit a lot of different biases in their area of expertise, not in other areas, but area of expertise, it's not problematic in that sense if we are aware of what kind of biases occur, then we can control or manage that in some ways. FTT also do two predictions that are different from other dual process theories, that expert decision making rely on gist representations in the area of expertise. And this is also sort of contradictory to the type 1, because to the type 1, gist representations would be considered to belong to there, even though in the FTT it's the essence of the decision making and involving high-level cognitive processes, even though it would be conducted as more fluent process. And the second one is experts show more biases than novices when decision based on gist. So if decision is based on verbatim or descriptions, this doesn't happen so much, but then it might affect the quality of the decisions. So there's always these trade-offs. So FTT has been also studied in different kinds of experiments with different kinds of expert decision makers. And it is seen like a new kind of intuitionism, because often if we consider decision making and intuition is per se not in favor. But this FTT tries to bring the gist representations as a new kind of intuitionism. It has been studied with security experts and intelligence agents and judges. And then in terms of judges, there's a contradiction to Kahneman and Friedrichs, the intuitive type 1 responsible of inaccurate judicial decisions. And then also with medical decision making, and they give this example that even though we would have the long list of different kinds of symptoms, and we would have a cookbook of all of those, still we do not have, at least yet, that kind of computational approaches that would sufficiently involve all of these, that we wouldn't need this gist-based decision making. So this FTT is one example of highlighting how the decisions from descriptions and from experience can be understood, and how this is in contradiction to the more traditional dual process theories. Then we move to cognitive biases, which are often termed as judgment heuristics and cognitive biases, and the HB approach, heuristics and biases approach. And since Tversky and Kahneman, there's a large number of biases in human judgment and decision making. if I remember correctly, there's maybe 150 of those, and the amount is increasing. Judgment heuristics are seen as a mental shortcuts. Cognitive biases are faulty mental processes that lead judgments and decisions to violate commonly accepted normative principles. And also a subcategory of cognitive biases are motivational biases, that the judgments influenced by the desirability or undesirability of events, consequences, outcomes, or choices. And the motivational biases have more recently gained attention in the JDM research community. Here is a table from Gonzalez in which the relationship between judgment heuristics and biases are presented on the basis of the most common heuristics. So representativeness is related to these biases in here. And availability. Probabilities are assessed by the ease with which instances or occurrences are brought to mind. So what information is retrieved the easiest affects the leads to different biases. Adjustment and anchoring is the third one, that the estimates or judgments are made on the basis of the first initial value, or what that you anchor your evaluation and judgments to the things that you have started the process with. So heuristics are the mental shortcuts that can involve, or different biases can be connected to these heuristics. This is the Cognitive Bias Codex. It's from Wikipedia. And just an example of the vastness of the biases. These all are different biases in here. And in this codex, they have been mapped to 4 different categories. And in the Wikipedia page, you can interactively look through these different kinds of biases visualized in this image. One example of mere biases is mere exposure effect, also titled as mere exposure bias, depending on which context it is discussed. In JDM research, it's titled as bias, but then, for example, in psychological information processing fluency research, it's titled as effect. So same thing, but different kind of assumption or approach to the topic. Mere exposure effect refers to the stimulus repetition increase likability. So its simplest forms, that just exposing some stimulus increases its likability. It usually holds for repetition of 10 times. After that, it can lead to boredom. And it's dependent on the exposure duration, of course, and also in terms of complexity. If the stimulus is really simple, then the boredom happens more quickly. If it has more complexity, then it can sustain more repetition times. So there's always also a sort of need for reasonable amount of complexity. And of course, this happens through familiarization, and then it has effects about how the visual appeal is adjusted and how it's accepted. And there's also this twofold exposure effect, and it depends on the stimulus first impression. So This is the basic one. But then the twofold is that it depends whether the first impression is positive or negative, then the rate of exposure follows the same trend. This mere exposure effect has also been utilized in many different ways in marketing and designing, and it's not modality dependent in that sense that it doesn't only occur via sight, but it's also via taste or through sound, so not modality dependent. But it's good to understand that it's not so straightforward in that sense, because the repetition, of course, increases the familiarity, which increases the cognitive information processing fluency, which leads to more likability. That's the basic idea of information processing fluency paradigm. But then what are the affective dimensions of this kind of experiences are not so straightforward, because of course through affective appraisal, the meaning of the encounter is constructed so that what kind of affective appraisals occur is not so straightforward, in that sense that if I'm exposed to some really basic everyday object, it can lead to that kind of way if I have a positive first impression that I start to like it, but still it doesn't necessarily play a really important role in my life. And also the constant exposure to a stimuli leads to habitation, so that we see something as safe. We don't need to adjust or respond to that kind of exposures. So that refers to reduced responding. And this can also, through the habituation, make things often occurred something that we don't pay attention to those anymore. So there's also a different way of thinking about the repeated exposure. And as a result of the orienting response to changes in the environment, things that very automatically attract and maintain attention. So some variance is needed to restart the attention towards this kind of events. But then if the variation is sort of repeated and automatic, then they maintain the attention. So it's not a one-off event. Now that we are in this stage of the tutorial, it's good to have one picture of a panda. And this is a really cute image. And I selected this on the basis of reflecting affect bias, because in one article it was utilized as an example of affect bias, that it has a huge impact on decision making in which way the information is presented to a human. In that example, people need to do judgments related to panda bears in an experiment, and the presentation, the information, it was presented as a graph about was it how many pandas live in what kind of areas and what resources were allocated to improve their surroundings. And then the other and on the other condition, the same information was presented with images of pandas. And of course, more resources were allocated and the importance were considered as much more important in the condition where there was these images of pandas. And now just when I'm looking at this image, this can also incorporate baby face bias, That is that if the proportions are similar to proportions of babies' face and head, then usually it's favored by humans. So there might be a baby face bias also occurring in this while inspecting this kind of stimulus. Baby face bias has also been incorporated in different design contexts, but that also illustrates that how to incorporate different biases for different purposes, because those are not always things to be avoided, but those are also utilized to guide people's understanding and experiences. So the baby face bias has been utilized, for example, in car design, but that says also that it's not so straightforward, because it's not predicted that everyone would favor cars that has similar features like the what is it in English? Or the car that has a huge front lights like eyes and it's round shaped. So towards debiasing, of course, in decision making, biases are something to be detected and to be avoided, and debiasing is focusing on that. So the problem of how to reduce or eliminate the impact of biases in reasoning, decision making, and problem solving. And here's 4 different perspectives to debiasing by Evans. And this is the same Evans that was in the critical review article of the dual process theories from 2013. So he's one of the authors that have been publishing and studying biases and heuristics and dual process theories in decision making for many decades. In 1990, Evans suggested these 4. First one, replacement of the human intuition by a formal procedure. So that computers as powerful tools under full control of their human masters. And this kind of way of debiasing is done in the research area of knowledge engineering by AI researchers of investigating human experts' decision-making processes. So human masters sounds nice and still quite important in 21, even though stated in 90. Second one, also currently highly pursued in JDM research, is to decrease biases by education and training to improve reasoning ability. And it's usually approached by incorporating critical thinking skills, and also acknowledge that it's highly affected by the presentation of information and context factors. And one problem in this is that verbal thinking and instruction are ineffective for non-verbal, intuitive, and implicit reasoning. That this kind of instruction based on verbalization impact only explicit thought processes, and many biases can also often occur implicitly, so that there's this kind of problem in the education approach. But there are some ways to overcome this. For example, overcoming positivity bias by providing positive label for an alternative that is normally seen as a negative one. So this has been seen to overcome some problems. Third one is improving the design of the environment in which the human operates. For example, user interface design, features of task presentation, avoiding biasing thinking. And in this, Evans cited Donald Norman, which is the one main authors. He has these really highly influential books, for example, Design of Everyday Things and Emotional Design, and he's a grand old man of cognitive science and he has incorporated cognitive scientific knowledge into technology interaction design. So this importance was also already stated in the 1990. And he suggests Barston's selective scrutiny model that could be incorporated, that the likelihood in scrutinizing arguments for conclusion in conflict of prior belief, that if we present some arguments that are in conflict to common prior belief, those are more likely to be highly paid attention and scrutinized towards a conclusion. So we can in these kind of ways encourage in-depth decision-making processes. And the fourth one is the development of interactive decision aids. And Evans says that these are more promising compared to one. That the problem structuring for effective mental models compensating working memory limitations. And it refers to computational procedures, and he thinks that anyway, if computational procedures are presented to decision makers representing the description and the information to which the decision making is based on, it already enable the biasing. And of course, if we compare that, we wouldn't have any tools that aid in thinking. Or if we would only have pen and paper and somebody telling us the different objectives and values. So it's understandable that the computational procedures already enable debiasing. Then more recently, to the discussion of debiasing, there's also affective debiasing. And this has been quite extensively studied in the medical domain of decision making. And affective debiasing is seen as a process of different stages, and it it states that debiasing is correlated with critical thinking ability, and critical thinking ability in this is defined as self-regulatory judgment. And in affective biases, debiasing, it's also noticed that as majority of our daily decisions involve these type 1 processes, these intuitive, fast, we would also need to ground the education of debiasing also to involve intuition and understand how that works, not that could be based on improving the critical thinking abilities if we would also educate about intuition. But according to these authors, affective debiasing can be approached with these kind of strategies, affective debiasing strategies. First one is recalibration, that if the DM anticipating additional risk, recalibration may reduce error. Group decision strategy, crowd wisdom in complex situations can be greater than an individual decision makers. This group decision strategy is something also that Gonzalez in 2017 stated as the most important future research direction, that not only focusing on single decision makers, also in the expert decision makers, but to move forwards to group decision strategies, and then also understand how the different decision making process models can explicate the group decision-making strategy. Then affective debiasing can be decreased, or affective debiasing can be done by personal accountability, so that if people are aware that the decisions they are making is going to be scrutinized and they are accountable of those, and the decisions are not made as anonymously, that might improve performance. Then exposure control, limited exposure to information might influence judgment before an impression is formed. So this is trying to control the mere exposure effect or mere exposure bias. Then there's also these forcing functions, that this is one example of those, how we can force people to do something for debiasing to occur. One way is to consider the opposite strategy. So seeking supportive evidence to a decision opposite to initial impression. And this would lead to less biased judgments of personality traits. So these are some strategies to overcome affective bias. And overall, affective bias hasn't been studied so extensively as cognitive bias, but the research is ongoing. Then we have few slides about cognitive load. First of all, cognitive load theory, developed by Sweller in '88, still publishing about it. So it's an instructional theory based on knowledge of human cognition to generate experimental instructional effects. Concerned with techniques for reducing working memory load in order to facilitate changes in long-term memory associated with schema acquisition. So, cognitive load theory is concerned with the capacity of working memory and how we can improve the schemas through instructional effects. And the cognitive load theory divides into 3 types of cognitive load. First one is intrinsic cognitive load, which refers to complexity of the knowledge acquired without reference to how that knowledge is acquired. So it's the intrinsic complexity of the information. It's fixed, unalterable, and it's the complexity of the information being processed. Extraneous cognitive load refers to how the knowledge is acquired and how the information or tasks are presented. And germane cognitive load refers to the effort put into creating a permanent store of knowledge, so that how this is developed into a schema. Then there's Mayer's principles. He's the other highly cited grand old man of cognitive load theory, and he has published these different multimedia principles of decreasing cognitive load already maybe 2 decades ago or 3. But this is a newer article because in this one there's evidence-based and theoretically ground principles for reducing extraneous processing of cognitive load. So his principles are based on the extraneous cognitive load, and these 5 here are ones that have been experimentally tested. So there's more than these, but these are the ones that contain empirical evidence. Coherence, signaling, redundancy, spatial contiguity, and temporal contiguity. So, and then there's exact information or definition, but this can be also seen as a design principles of how to present information to people, of not to cognitively load with the extraneous processing. There's also a way of extending working memory, and one is modality effect, which refers to dual coding theory by Paivio, so that the mind processes visual and auditory information separately. So we don't bombard working memory if we present information through these different sensory channels. That's a one often utilized approach. And other way, of course, is to utilize existing established schemas based on existing knowledge, expand the capacity of working memory. So if we can communicate issues that has relations to established schemas, then the processing is much more quicker. Here are the three theories that the cognitive load theory is based on still nowadays. Then how to measure cognitive load. This is one example about NASA TLX. So it's a level of experienced workload. And there's also a raw TLX version, and it has gained popularity because it's simple to apply. In the original NASA TLX, it has been operationalized with these components: mental demand, physical demand, temporal demand, performance, effort, and frustration as a semantic differential. But then it also have the weightings that respondents can give weightings of what components are more important in the evaluation of cognitive load in some specific condition. But raw TLX doesn't contain the weighting. We recently, in Kaisa's research group, we conducted an experiment of interactive methods of multi-objective optimization. And we wanted to understand how the cognitive load is experienced differently between the different methods. And even though how much cognitive load has been studied, there isn't any validated measurement for exactly that context, because some of the components here are not applicable to this kind of context, because this has been developed in the time and safety critical interaction context, which has these kind of items that with these the cognitive loads can be measured. So we designed the way that we measured cognitive load in this experiment. We weren't able to use any validated measurements, but we of course utilized some of the components in our study too. So, despite decades of research on cognitive load, the direct measurement of its key concept, cognitive load itself, remains elusive. So it's difficult to find, or there isn't any that kind of course, depending on the research context. NASA TLX is really often utilized, and it's really often utilized also in contexts that are not time and safety critical due to that validation. And there's numerous different articles explicating the context applicability, how to interpret the values, and many of these kind of things. So it has a clear advantage whenever it can be applied. Overall, measuring cognitive load is divided into two categories. First one is these error rates, total task time to reach problem solutions, and dual task methodology. So that we could error rates and total task times have some kind of objective data that we can compare how cognitive load occurs in these terms. Dual task methodology is a way that we have tasks to be conducted at the same time with different measurements, and then we see how cognitive load happens in this kind of setting. Second one is self-rating, Likert scale measures for perceived amount of mental effort. So NASA TLX is also a measurement for perceiving the amount of cognitive load. Here the term is mental effort because the article is from the educational aspect, educational research area, in which in those measurement studies, the mental effort has been operationalized in a way that it can reveal the cognitive load. So there's different ways, different conceptualizations, different definitions, and different operationalization in different research areas of how to measure this. And of course, these self-rating scales, perceived amount, these are based on the assumption that individuals are able to make reliable, valid estimates of the amount of cognitive effort they are expending in a given situation. So that's the basic assumption of it. Might also be good if some metacognitive aspects would be incorporated, and especially by combining objective and subjective data. These type 2 ways of measuring cognitive load has also been criticized about the single point retrospective way of measuring it, that after some task has been done, then there's only one single point that is measured afterwards. So it questions the validity of the results, because then they are based on memory. So better would be that it would have, for example, multiple measurement points and not only retrospectively. Then there's also problems that if we do this kind of way of measuring, are the participants really assessing the cognitive load they experience, or is it the cognitive load of the difficulty of the task? So there's that kind of like bottom-up, top-down confusion sometimes also occurring. But these are considered to be sensitive to intrinsic load measurement, and these are unobtrusive. Also, recent research has also incorporated physiological measures as considered as a direct objective way of collecting data. Then we move to the last section. So few insights into cognitive control and uncertainty. Cognitive control is the ability to rapidly and flexibly adjust behavior to changing environmental demands. And of course, cognitive control is seen essential in decision making. Ability to shape behavior in adaptive manner in terms of current goals and constraints. And it activates a category of processes when automatic schemata is not sufficient for successful adaptation to the environment. So conscious attention demanding involve flexible coordination of several cognitive processes in order to attain a specific goal. So that is cognitive control. There are different contextual conditions that signal for the need of control. If people detect errors, cognitive control processes might be activated. If there are changes in the motivational value or goal relevance of the environment, conflict between competing responses, it's bolded because, of course, in this crisis research group, this is something essential, and changes in the prediction of error likelihood. So these are few of the contextual conditions. There are also different kinds of theoretical models and definitions of cognitive control. all contributing to the sort of understanding which is in line, but different ways of approaching it. And here are the references if you want to have more information about it. So, cognitive control in decision making, and especially in complex decision making, it requires variety of strategies to simplify representation of problems. It requires adaptability to subtle changes in dynamic selection of decision strategies that is based on goals and available cognitive resources, and also to exert strategic control and switch between strategies. So these are three main issues in complex cognitive control in complex decision making. And these kind of quotes quite frequently I came across with these kind of research gap statements quite frequently, and I believe that that's true due to the fact that there are so many different kinds of disciplines involved in this kind of research topics. So different definitions and different ways of understanding it. So JDM research is definitely something that it benefits from multidisciplinary or interdisciplinary approaches. There are also different modes of cognitive control. DMC theory, which means that cognitive flexibility achieved by modulating which control mechanism is deployed in response to changing task demands or internal goal states. The first mode is proactive mode of cognitive control, and it occurs early selection of goal relevant information, and it involves anticipation before the occurrence of cognitively demanding events to optimally bias attention, perception, and action. So in an anticipated manner. Then the reactive mode, which is a late correction mechanism, requited only as needed. Then there's also hierarchical framework of cognitive control about episodic control and contextual control. And episodic control affects contextual control, not vice versa. Contextual control means in cognitive control that use of current cue for selecting task-appropriate behavior. And episodic control puts a time dimension to this contextual control, that the use of past cues determining for extended period of time the way that current stimuli and contextual cues are interpreted. So we have more understandability of how cognitive control can be applied and will and happens in decision making if we divide it into these different kinds of modes. Because the expected forms of uncertainty estimated and sustained by this proactive, this early mode, and with the episodic control. So there's a clear connections of the different cognitive control modes to different varieties of uncertainties in decision making. And unexpected forms of uncertainty are detected by contextual control and reactive mode, so the late correction mechanism. So this can also be utilized in understanding the different forms of uncertainty. Different varieties of uncertainty are these ones: expected uncertainty, SRO rules, so stimulus response outcomes rules from the past events are weak predictors of the outcomes of future actions, and this unreliability is known and stable. So there's insecurity, but it's anticipated. Then unexpected uncertainty. There are fundamental changes in the stimulus response outcomes that invalidate prediction based on previous experience. And the third one, volatility, that is frequent changes in these rules, and it requires constant updating of the rules. These are based on the SRO rules, the definitions of the different varieties of uncertainty. So the goal to manage uncertainties in decision making is to learn these relationships and the likelihoods to which they occur to make the most optimal choices. So in decision making under high uncertainty, there would be some ways possibly to incorporate these SRO rules. And that was the last slide. And here are the references. And I just noticed during the presentation that there was at least 8 references that I have forgotten to put in the reference list, but I'll update it when I send the references to Kaisa. And hopefully you are not cognitively totally loaded at the moment.
Very warm thanks to you, Johanna. While listening to this, I kind of felt that we should have had part 1, 2, and 3 of the topics, because there are so many important and relevant elements here. And I kind of felt that this has been cognitively rather loading session, because there are so many terms and concepts that you kind of need to think and try to digest and remember.
Yeah, that's true. And I hope that if there were some issues that gathered your interest, then you can utilize the slides as a sort of like a library, that you just check the slide that was interesting and then see the references from the reference list.
Yes, this has been an excellent overview and captures huge amount of relevant topics. Maybe we should stop the recording now and